Okay, let's talk about streams on top of Scala. My name is Quentin Adam. I'm the CEO of a cool company called Clever Cloud, and this is my day-to-day job. Basically, we're a company, we're able to run your application on top of our server. You just git push and we take care of everything. It's self-service, it's very simple to do it, and nobody has nothing to do to us something in our cloud. And we have customers in about 60 countries now, and we learn a lot because people push a lot of code in our platform with node.js, PHP, Scala, all those things. And we learn a lot about what is a good practice, a bad practice, good ID, bad ID, and how we can help people to improve the way they work. So, why streams are so trendy these days? In fact, if you think about it, there is two main reasons. In the today web, data is becoming bigger and bigger. So, as the data is big, we need to act while the data is transferring in the network, because we can't wait. And the other reason is we are now using a lot of streaming connection and permanent connection. So this is a reality for many developers. Who is using WebSockets? And who have heard about HTTP 2? So I have to say, lots of people have raised their hand there. I think it's one of the best proportions I have seen in every conference I take. Okay, so congrats to you. So, just take an example. We can have an HTTP request, okay? And this HTTP request is basically a verb, a resource, headers, and a body. And in many language or framework, what you do is manipulating all the requests users made inside the memory, okay? But now, what do we do if the body people try to upload is a 20 gigabyte file? If we want to push it in the memory, we can have a big problem. Okay. Most of the people say there is not a problem, we just create temporal file just somewhere in the hard drive. If the server fails, it will, okay, we will lose it, but server never fails. We know that. And there is another thing, this I8 file system. If you think about it, I'm one of the people who have to handle file system every day, and I hate file system a lot because file system is something with bottleneck, acidity, POSIX, and it's quite complicated to interact as the modern developers with something located in only one server. So today, if you think about it, what we can do is, okay, client upload a file, we create a temporary file, we send the file to the backend, the client timeout because he's waiting too much, and we say to the client it's okay. The problem is we transferring the file 2 times. And it's very, very stupid, in fact. We don't use the full possibility of what we can do today. And if a client uploads a file, we can directly stream to the backend and answer the client it's working. Okay? So basically, this is one of the basic operations we need to act on stream. But we can do streaming for years now. It's working a lot. So let's do this with Java. We create a file input stream, we create a file output stream, and we have something very cool. We create a while. Basically, we use the while true pattern. It's a very great pattern, and we say, okay, we take a byte, we put a byte, we take a byte, we put a byte. And anyway, at the end, we close all the stream. So It's working. Yeah, but it will be very slow. Oh, no problem. We can add buffer, buffer management, buffer exception, buffer overflow. You know, Earth bleed is not so hard. Buffer never take a break and never cause any problem. We know this all the time. If you want to go to the buffer mafia, okay, do this. But for me, it's not. The performance is low. It's not very modular, and it's thread blocking. So you have a thread on your servers which handle only this stream, and the code is very ugly because something very crappy is you have to mix the Plumberry IO code with the business real logic code. And the two code is very, very, very complicated and imbricated, so it's not very cool. And there is no back pressure. The error handling is bad. Really, when I put this kind of code online, I can't sleep at night. So we have to find a better way to solve the problem. In fact, when we come to functional programming, people thinking, okay, we can find data structure to express data stream management. It's what is going today on the Play framework with Play Iteratee module. What's doing Play Iteratee is giving you some of the great function you can use. First, you have the Iteratee, who is basically a recipe explaining how to act on the data stream. Now you have an enumerator, which is basically an output data stream, and the enumeratee, which is basically a lot of things to mixing all of this together. If you build a very simple example to start, we will get all the word of the reactive manifesto and stream into an iteratee to pair it by two words. Okay, so we have something outputting the iterator word, the reactive manifesto word, and we want to group it by pair and then print it. So we built the enumerator. We have something cool. We can put all the enumerator, and it will spread words forever. And we built an iteratee. Basically, an iteratee is a very simple thing. It's an input who can be end of file, empty, or I have an element. And you have the iteratee state who can be done, continue your work, and there is an error. It's quite simple. So if we build an iteratee aggregation world, we see, okay, we build an iteratee. This iteratee have a function which is step, and step is something who can take care of an input, who can be end of file, empty, or element, and return a continuation. And at the end of the iteratee, the last line is the first continuation we built to bootstrap the iteratee. It's just a data structure. And we put it with an enumeratee to see, okay, what we want to do is use this iteratee to group words together and put it in another iteratee with the log stream. It's very not interesting because it's just a println. So, how is it working? We have the application, and it's running well because it's only running on streams. Okay, cool. Now, let's take this iteratee and make something more complicated. We take all the letters we received and we say, okay, what we want to do is only 5 letters word. So, like the other thing, we just built an iteratee which is just a data structure, and we're using end of file, empty, and element, and we're using a buffer system very low to just have 5 letters element. So, is it working? Okay, I record video for this demo because I was, lazy. And we can see, okay, we group this data by only 5 letters words. But what is interesting with Iteratee is the composition. So if we say we want to build the first Iteratee, which is Calify words, and then group that by word aggregation, which is our first Iteratee, which take 2 words together, we can composing it and make a new Iteratee, which is able to do something cool, which is 2 5 letters words together. Compositing is very genius because it's one of the funny thing about being purely functional. Okay, what do you? Purely functional system, because all is based on function on the type system, and it's all type safe, so it's okay. And we can work on composition and team. It's cool. But the problem with Iteratee, it's dying. The backend engine of Iteratee on Play, it's based on Netty. And it's very hard to maintain and very hard to manage the streams and the threading because it's all have to be built on the backend. We launch Iteratee. So you rely on the backend to manage it. And an Iteratee is not bidirectional. So basically, for example, in WebSockets, it's not very great. You have an enumerator and Iteratee, and you have to manage the two. It's not very cool. But the reason I show you today the Iteratee is, for me as a developer, it's one of the biggest time I understand how to manage streams. So this is why I wanted to show you that. So, it's trendy on the Scala platform. Basically, it's dying, but it's working today. Okay, so if you need to put something with streaming on plays today out, it's working very well. We have code in production at Clever Cloud. We're working and rely on that, and it's working very well. So basically, it's trendy. Sorry for TypeSafe, but I want to speak about scalaz.streams. Scala.streams is something very interesting because it's based on the Scala basics. So you have all the library included, and all is based on the idea of a process. And you booting the streams inside the process, and after that, just use the simple collection API you already know. So basically, you can map, you can fold, you cannot be something like dot size, obviously, but it's very simple to use. It's time to make a new demo. So, a real demo. I have a problem with PowerPoint. Maybe it will be kill off my Mac every time I switch. Okay, this is the example. Basically, what we do is quite simple. We have an application. We take all the line of all the books of Asimov, filtering it to say, okay, I only want the lines with robots, and put a new lines and put it in uppercase and print a dot so you can see the stream is going on, and put it in a new file. Okay? As you can see, the code is quite simple there. Just do the demo thing. Okay, this is the file we want to to get the data streams. And now we can see if we can launch our application. So basically, we launch the application. And what you do is, as you can see, the streams is processed to the file at the same time of we processing it to the system. So basically, we are really acting on the file, and we're putting a dot for every lines of the code we process. And there is a lot of files. There is a lot of line on this place. Okay? You can't see it because if I remove the filter constraints, I think the terminal will not like it. But we put a lot of line working out there. So this is our scalaz.stream handling the thing, using the plain old composition API of collection. What is cool with scalaz? Okay. Big ways. This is the problem. iTerm don't like when I'm acting on streams because it put a lot of lines in my terminal. Okay. Be safe. I will be calm later. Okay. So, what is interesting with scalaz.stream, there is an HTTP binding put with Netty and another thing calling HTTP4S, which is based on various Jetty and something like that, streaming HTTP platform. And there is a binding very interesting with scodex. And scodex is a library to processing binary and manage binary data on top of Scala. So I think you can use scalaz.streams for something like handling binary systems using scodex and putting in another codex and something like that, because it's very powerful. You can do something, for example, with MP4 or something like that on top of scodex. But we need to talk to each other, because we have a problem with the Scala world. It's we are alone in our own solution. So we need to talk to our friends on top of the Java virtual machine. I think it can be a very good idea. So the problem with this friend, if they have, I can't say a shitty type system, but okay, I can say it. But the thing is, they can do a lot of things very great with the type system. So we have to lower what we can do on the Java, on the Scala platform. And there is another thing, it's the political relationship between companies. I see it. And all these guys are working together and make something great. It's called Reactive Streams. Reactive Streams, it's the JVM unified way to streams, to talk with Groovy, to talk with all the Scala, the Java 8, and all this kind of thing can work on Reactive Streams. It's designed to make the I/O plumbery and the process. When I say this, it's sure, streams can be very great for just doing the I/O plumbery. But if you think about it, you can build your streams to be a process modeling for business process modeling. Okay? We are lucky because Aka Streams is working very well right now. It's currently the M5 milestone, so you can use it right now. It's based on the Aka actor system, so you have all the powerfulness of the Aka actor system. Basically, how it's working is very simple. You create some function, you will use it later. You say, okay, I want to print something. I am a flow acting on a type, and I use map to say, okay, I'm working on this. And I can say also I am a flow acting on string and making this uppercase. Okay? It's just a basic flow system. When you launch it, you have something interesting like you're starting an actor system. Then, you have to have a dispatcher and a materializer. Materializer is quite interesting because if you are an Scala stream, you can say, okay, I want my flow is running on thread, I want my flow is running on actors, and basically you can put your flow on a GPU system if you re-implemented a new flow materializer. And after that, you import all the implicit. But after these few lines of import, what is interesting is you say, okay, I'm making a new source. So I have a streams coming from this file. I have an output strings, which is nothing because I don't want to write it. And I will get all the lines, put it to the uppercase method, put it to the print method, and output it. This is quite interesting. You can do something very interesting with this because there is real process modeling. And then you start your flow. Okay. I will demo it again. So this is a code. I have the flow factory, and I have the flow initializer, which is running very well. What I do to this is quite interesting because I want to show you something more. Is I say, okay, my data is complex. I want to model it in many ways. So I create a broadcast thing and a merge thing. And I say, I take my input, I put it into the broadcast, then to the uppercase, to the merge, and we print it and we output the data. And the broadcast is just connected to the merge. So basically, we will have for each line the uppercase and the standard case solution. Because we can split and reform flow graph. So just create a new demonstration about that. You don't like me a lot. Okay, I will launch another terminal to do the demonstration. Okay, here we can see we have for each line the two lines handling and printing it for all the file. So this is cool. Why this is cool? Because what we can do is lines are not streamed together. If one pass takes more time, it's not a problem. It's not something like you handling in loops or something like that. You have to compile the streams. If you're looking at it, what's interesting there is the application was on a Play framework application. So you can use Scala Stream inside your Play framework application and it will be working. So it will bring to you more possibilities because you can grab data from RabbitMQ, pass the event, check event ACL from the DB, find a reliable WebSocket, and send data to the WebSocket. This is basically one of the top system architecture. We use it on Clever Cloud. And it's working like that. We have connection to the RabbitMQ. We create all of the exchange and things like that. Then we have something interesting is we say the source is a RabbitMQ system. We can manage the buffer and the overflow strategy. And we have something cool is the output of the system is something we built ourselves is a WebSocket dispatcher tool. Then we put it on a flow, and all the data is processing from directly RabbitMQ to the WebSocket of people have the right to do it. And it's just about something like 20 lines of code. It's very simple to do. Okay. Basically, Scala Scream is very interesting because it's working on top of Akka. There is something very cool, which is Akka.io HTTP. Basically, it's a new version of all the spray thing on top of HTTP. And there is integration with RabbitMQ, with many databases. And writing a new sink and a new source, it's quite simple because it's just actors with just a few methods. So you can make business process with big clue batteries included. I hope I convince you to use streams. You can go outside. If you want to do something right now, use Iteratee. If you want to work with the functional guys of scalaz, give a try to scalaz.streams, which is very interesting. And if you want to sell it to a corporate company, use Scala Scream. I'm pretty sure the release is not far away. We're using it right now in production at Clever Cloud. So data stream is programming very trendy right now. So give a try to use it. I will thanks Clement to all the support he gave me to this presentation. And thank you for listening to me. And this is question time. Thank you.